Yeah. So then, I think that's the right. So I don't know if you know how long have you been teaching?
See, since 98. I started teaching when I was 26. No, it was on the East Coast.
This one.
All right, guys. Here's this is kind of nifty how this happens. Another name for the mean is the expected value. It's another name for the mean. So what would I expect to happen? If I took a group of people from this, what would I expect their average to be? I'd expect it to be close to 1.6. And watch, what are the first three kind of letters in this formula? Yeah, it's freaking P. I love that shit. So another name for the mean is expected EXP value. All right, I just want to point that out. So if they ask you about expected value in the homework, when you read that, just read mean. It's the same thing. I like it. So what we need to do now is to talk about, if there's a shortcut for finding the mean, there must be some shortcut to finding the standard deviation.
Of course.
It has to be. Please, dear God. So this is the way we did it before. Now, real quick, before I go any further, now that we've established this as being a good formula, it makes sense. It does the same thing that it did, like the way we did it before. How did I do this before? How did I find the mean before? We summed up the x's and divided by n, right? And now I'm saying, if we reformulate it using probabilities, it's this formula. Does anybody realize that these are the same damn formula? Because what's on the bottom of a probability? Total number, n. So that over n is built in. Same stupid formula. I like it. All right, cool. Maybe you guys do.
Yeah, your camera.
Oh, I'm poor little dude. What's the matter? Camera. Oh, it's fine.
She can't see the little dot out.
Over there. Boop. It's all right. They don't need to see all that shit. Okay. All right, guys. So I just put that there to remind us. This is how we figured out the standard deviation before, right? Calculated this, and then we added them up, and then we divided by how many there were. Notice the symbols I'm using. So I'm assuming this is a population. Why am I doing that? Because again, what's on the bottom of the probability? N. And a sample would need it to be n minus 1. Okay, good. Okay. And really, I'm not going to do that. So I really want this to make sense. When I multiply this times this, it's the weight times the value. The weight times the value. So if you wanted to calculate your average grade for this class, you would do this. So the tests are like 50% times your test grade, plus 20% times your quiz grades, plus, do you understand what's happening? This is a general way to calculate averages when the values are weighted. So I'd say this is the heaviest weighted value. Is that cool? And that's why the average was 1.6. Because it kind of dragged it down towards 1. All right, maybe. Okay, all right. So, if I multiply these by the weights and then add them up, and before I used to just add these up right away, right? So I'm not going to do these and add them up when it's giving me this. I'm going to multiply these by the weights and then add them up. Now just stay with me. I'm going to improve this formula. This formula right now sucks. It would take a lot of freaking work. I'm going to try to decrease the work we got to do. Let me just make sure you guys understand. Because doesn't that become this? Because again, what's on the bottom probability? N. Same formula. So if I did this and then added them all up, I would end up with the, well, be careful now. What would I end up with? What was this the formula for? Variance. I love it. It would be sigma squared. Let me write that better. Sigma squared equals this. Bam. Now, let's improve that formula. I want to make the formula so that I only need one more column and then I can get what I need. That's what I'm going to work towards. I don't think the book actually lists this formula, so we're going to use this formula. It's better. I'm going to leave this here because I'm going to do what we figured out to this. Okay. Now I need to go over here. I keep saying this today, but stay with me. We're going to do a little bit of, we're not going to do it all the way out. I just want to show you the first few steps, because this is not a summation notation algebra course. You could have an entire semester on just summation notation and how to work with it. So I just want to do a couple of first steps, so at least it makes sense where we end up. So I'm basically going to take this and work it out a little bit, and then show you where it's going to end up if I keep going that way. So what the shit am I talking about? Here, somebody help me out. If you're in algebra class and you see this, what does that sort of tell you to do? If I see x plus 7 squared and I say simplify it, what would you do?
Foil.
Foil it. I love it. X plus 7 is x plus 7. So I see x minus mu times x minus mu. Right? Just pulling that out. Okay, alright, maybe. Okay, so again, we're not going to do this all the way out, because there are some funky things that happen later that would take some time to explain why summation works that way. No. But you guys can do this. What do I get when I do that?
X squared.
Minus 2 mu
Minus
x
2 of these, is that cool? I like it. Plus
mu squared.
times p of x, right? And then what can I do with that p of x? Distribute. So that would be minus 2 mu sum of x p of x plus mu squared p of x. This is all in the summation. Oh my gosh. Isn't that yummy? Oh God. Thanks, Jeff. Now, like I said, to keep going would take some understanding of summation notation, how it works with itself, blah, blah, blah. You rewrite the mu using its summation notation bullshit. Kind of gather some stuff together. But look at the very first part, this. So where you end up, if you take it all the way out, where you end up is here. Let me put it up here. If you keep going with that, you end up at this formula. So this is going to be the formula that we use for standard deviation. Well, for variance first. That first part that we see there, right? So we saw where that came from. That's the easiest part to see where it comes from. Now, believe it or not, all the rest of this becomes that after you simplify it. If you don't believe me, you can look it up. I can show you in my office, whatever. But there are several steps after that, consolidating stuff, canceling like stuff, and then you end up there. So obviously this is the variance. You calculate this, and then you take the square root. So let's try this. So how did I help? This doesn't look that much better, but I need the mean, right? And what do I need to do to get the mean? Get an x times p of x column. What do I need for the variance? I need to sum up those. So how do I get a column of x squared p of x's? I've already got a column of x p of x's. No, if I square it, I'll get x squared p squared. I don't want x squared p squared.
Multiply by the first.
Multiply by x. So if I've already got x p of x and I multiply by x, isn't that going to be x squared p of x? Aw. Somebody's like, I was told there wouldn't be much algebra. There ain't much. There's some. Alright. So how do I do this? And again, take good notes, but I also have this handout that's got all this again. Not the derivation, but the actual formula and stuff. So if you want to rewrite this data from earlier, I'm going to just kind of calculate the standard deviation off of this. Now, a few mistakes people make, you got to be careful. When I make a row of x squared p of x's and I add them up, I still have to do the rest of this. right? I still have to plug it in the formula. It doesn't become the variance. I still have a little bit more to do. So I want to make a column of x squared p of x's. So then I'm going to multiply this times this. Do you see how that makes what I want? Again, if I'm given a formula, I cover that up and I say, I've got to make a column of this. Well, how do I make it very easily from what I already have? Multiply another x. So what does that mean practically? 0 times 0 is 0. 1 times 0.4 is 0.4. 2 times 0.6 is 1.2. 3 times 0.6 is 1.8. So I just took L1 times L3. So pretty cool that. You guys see how that makes x? You could also do L1 squared times L2. You know, I don't care. One of those two to make it x squared p of x. And then what do you get when you sum x squared p of x? What do you get when you sum those up? You get
3.4.
3.4. I love it. Now that's not the variance, because the variance formula says, okay, I need this. Sure, I got this part. This part is 3.4 minus the mean squared. Then that'll be the variance. That's the formula for the variance, so I've got to do that also. That was all the extra shit that became this. So to get the variance, what's this here?
3.4.
3.4, yeah. We calculate that. And what was the mean? 1.6, right? We did that one earlier. The mean is 1.6. Is that cool? Let me stop there for a second. Some of you guys look like you have a question, but you're not sure what it is. Yes? Yes, and so I'm just going to keep going with that. We calculated the average already, the mean. Now I'm going to keep going one more step and calculate the standard deviation. That's why I said you could recopy this down in your notes and kind of work off of it. You guys with me? I'm calculating the standard deviation for this same set of data. Right? Is that cool? So of course the average is 1.6 because I'm using the same set of data to do this. I like it. It just was nice numbers and it was right here, so I thought I'd just keep going with this. Alright. So this would be minus 1.6 squared. That's going to be the variance. Somebody help me out. What's 3.4 minus roughly 2.5? Now in your calculator, don't round, right? On the paper you can round.
No, that's the flat.
What do you mean?
1.6 squared.
Oh, that you did 1.6 squared. All right. I'm talking about what is that?
0.84.
0.84? Okay. I like it. Let me stop there for a second. Nothing major just happened. And then you take square root to kill those stupid squares that we had to put in there to kill the negatives and blah, blah, blah. Right. Sounds like the lady way to fly kind of thing. Square root, square root.
0.91.
6.5.
6.5.
6.5? Blah, blah, blah? Or 6.4?
6.5.
6.5. All right, so 0.917. You put 0.92, you're losing a point. Oh, Jeff, you suck. Oh, too bad. What did I say? Standard deviation has to go at least 3 places, and that is a standard deviation. Yes?
So when are we going to start bringing in the floor decimal?
Oh, for probabilities. The reason I do that is the chart we're going to use to look up probabilities goes to 4 places. I just want you used to doing that. I like it. The reason I do this at least 3 places is it reduces the error due to rounding by an acceptable level. I mean, I don't know how else to say that. There's other ways to round things and whatever, but that's the one that kind of captures most of it, makes almost everything work. All right. So let me do this. Let me, I really want you to understand. I have to do these. These have to be given to me. They have to give me both of these. There's no way I can calculate this unless they gave me the list of data, and then why would I do this shit? So they got to give me these. We have to do this row anyway, this column to get the mean, and then this comes off of this. So it's just one more column to then be able to calculate standard deviation. That's pretty good. Let it be okay. Let it be good. So let me give you the handout. And again, just like before, I like to do this. One side is a completely worked out problem, and the other side is the one I want you to do right now. I've got labels about how you would do this in your calculator if you wanted to. But it's not like a huge set of data, so you don't have to.
So the sum of P of X equals the mean.
Yeah, the sum of x P of x is the mean. And then that is used to figure out the standard deviation.
Okay.
You're going to see some very familiar sounding questions on here. Because once you calculate those, I can ask questions that I've asked you before.
This looks.
All right. What? Oh, yeah, she is missing. That's you.
Nobody was over there. That's I'm merging the days now.